Hi friends, welcome to the Unit R Day 4. This is in the factoring packet. Today we're looking at page 4. Page 4 is all about perfect squares. Perfect squares, first you want to do is check to see if there's a GCF, and that's going to be what you do always before you do anything else. If you have 2 or 3 terms, then you could see if the n terms are perfect squares. If they are, one of the factoring patterns can be used. So I'm saying the n terms. What do I mean by the n terms? Those are the terms that are on the outer side, so the outside. So if you look on the outside terms, see if the outside terms are perfect squares. So an example, over here off to the side, we have a squared minus b squared. A squared is a perfect square. B squared is a perfect square. In fact, this is a difference of squares. And so the difference of perfect squares, we find the square root of the first term, and then that goes in your first spot. You take the square root of the last term, that goes in your second spot, and then you put a minus and a plus. Both of these values are going to be the same, so you're just going to have that part being the difference, one of them being positive and one of them being negative. And there's some examples over here to kind of showcase exactly what I'm talking about. When you have some other perfect squares, you might have terms that give you kind of a third term, a trinomial. And the reason behind that is because you have basically 2 that are addition or 2 that are subtraction, but they're going to be the same result. An example of that is this x squared plus 8x plus 16. X squared and 16 are both perfect squares. Your middle term is 8x, so this is a perfect square. You just got to be careful in that middle term because it's not always going to be exactly what you want it to be. In this example, it worked out fine. Some of them later on, they're not, so just be careful. Just double check. Let's go ahead and do a couple of these together. I'm going to do number 7. So 7 is 64x squared and y squared. I'm checking to see, are both of those perfect squares? 64 is a perfect square. X squared is a perfect square. So both of them together are also a perfect square. And then y squared is also. Now I'm going to go ahead and check this middle term because that's where I'm really confused about. This middle term right here. Oh, okay. What's going on here at that middle term? Well, if I take the square root of 64x squared, I get 8x. So again, if I lay this out, that's going to go in my first slot on both of these. And then the square root of y squared is y. That goes in my second term on these. Now if I check this, well, if I have 8x times y, that's my last part. If I take 8x times y, let's see, that's going to give me 8xy. And then if I have y times 8x, that's going to give me also 8xy. And if I add 8xy and 8xy, I get that 16xy. That's that middle term. So that's why it works out in that particular way. You have to be careful when you put signs for this. For this particular one, to get that, to have that middle term of 16xy, I have to put plus plus, not plus minus. Plus minus would actually get rid of my middle term, and I wouldn't have a middle term at all. So be careful with that. Just note that if you have a middle term, in this case, you will then have the same operation, symbol, so in this case, plus, adding, addition, in this scenario. The next one I want to do is number 10. So 10, I have 36x squared minus y squared. Again, 36x squared, perfect square. Y squared, perfect square. So if I take the square root of 36x, I get, 36x squared, my bad. 36x squared, you get 6x. And then if I take the square root of y squared, I get y. Now for us to have the middle term eliminated, then I'm going to have one of them being positive and one of them being negative. Order doesn't matter. It doesn't matter which order you put. Remember, we're multiplying here. The symbol between both of these set of parentheses is multiplication. And that is commutative, which means it doesn't matter the order that we put it in. The next one I want to go over is 15. So 15, this one looks a little bit tricky. And a lot of students jump into, we just done factoring perfect squares. Why isn't this a perfect square? Let's check for a second, see what's going on. I can take a GCF out of this first. Let's do that. So if I take a GCF out of all of these, I'm going to have to factor out the greatest common factor. The greatest common factor is 2. I can take a 2 out of all of these. And an m squared. Let's see what I'm left with. So I factor out a 2m squared from 14m to the 4th. I'm left with 7m squared. 7m squared. And then plus, if I factor out a 2m squared from 10m cubed, I'm left with 5m, or 5m. And then minus 1. Mr. Brumman, that's not a perfect square. You're exactly right. Be very careful. Read the directions. It says review some GCF problems. All we're doing is just reviewing from some GCF problems. If you have any questions on perfect squares, please reach out to your instructor and they will help you out. Have a wonderful day.